Thank you. Welcome to my work in progress talk about BDD development in Tcl 8.6 and why TCL was a good choice. BDD development, BDD stands for behavior-driven development. The idea is to get to better software through better communication, talking between stakeholders earlier in development, a wider group of customers, and end up with better specifications and acceptance test skeletons. This talk is not really about BDD, but I thought some background will be helpful.
Can you speak a little more loud?
Sorry? Louder, okay. The basis of BDD is the Gherkin language, which was originally written by Ruby programmers, I think. But the behave that I've been using was originally Python-based. The Gherkin language is a little language, just features, scenarios, and steps. Yep. Wow, this isn't going to work. So the idea is that it's a natural language, an informal language, multilingual with many aliases to make it more popular. It's line-oriented. A keyword starts each statement, and there are hashtags for comments. This sounds familiar, yes. So, features. That's one of the 7 or 8 things in the language. The idea is features provide context for scenarios. Here's an example. The feature is register for EuroTcl2018, and then comes some text. This has meaning only to the people who read it. So a user wants to register, let them. Within the feature, then there are scenarios, which are sequences of steps. Scenario 1, given certain preconditions. So the given is a step, the when is a step, and the then is a step. And you have many scenarios for a given feature. Here's an example. A user wants to register, given they have a browser. Then they can enter an email address, and then they will receive, when they enter an email address, then they will receive a confirmation. It goes a little further than that because end up writing too many scenarios, so they came up with scenario outlines, which are basically table-based ways to generate more scenarios. For example, banned users are rejected. Given a denied persons database, okay, I'm going to have to implement a denied persons database. When a user submits an email, then they get a response. And that's followed by a table of examples. So here, for example, the email field is filled out in the scenario with some test data, and whether they're banned or not determines whether the response is a rejection or a confirmation. So the steps we've seen, given, when, and then. And then they allow things like and but, which are just repeats of steps. So you can say when A is true, and B is true, and C is true. You don't have to do an unnatural when A is true, when B is true, etc. But there's certain things you can't do with BDD or are not supported. For example, or. I think you've had experience writing code. If you mix ands and ors, you start needing parentheses, and that makes the language a little more difficult. You can't just read it out into the group. It doesn't pass the telephone test, so they don't allow ors. So now let's do a quick field trip to the command line. This is an example of the multilingualism. These are the languages that Python behave supports. And I'm sorry, the closest I could get to Manchester was Scouse. So if this is the language you're expecting, you can use it. I saw someone is an Esperanto speaker. Esperanto is supported. Texan for people who've learned from Texans. Hungarian is possible. Italian and Estonian for our Estonian speakers.
Greek is not on the list.
I think Greek is on the list. I have a problem that I don't have all the fonts here. Greek is probably Hellas. All right, well, that's left as an exercise to the audience. All right. So the question we had is what's missing from Gherkin, or what can we use to make it even easier in real-world projects? The company I work for makes trains, for example, and other hardware-heavy things, not all done by software developers, and they have their own way of talking, and we want to get their specifications and features from them. And sometimes they would say something and we'd find there's no way to nicely do that. So here's an example. Sometimes we'd come across requirements like, given travel is requested when the first line manager approves and the accountant approves and the big boss approves in any order. That's something that's not out of the box available with Gherkin. So that's one thing we could look at, then the request is approved. So the particular area we looked at for improvement or to drive the example was test probes in an electric car project. It's been reported in the literature a little bit, reliable statements about a fault-tolerant something by wire. So it's not just drive by wire, it would be navigate by wire or run the air conditioner by wire. The idea is it has embedded hardware, and of course automobile manufacturers don't want to put more hardware in the car than they need to because every cent is too much. So we looked at several things to be examined. Trailing clauses, I will explain each of these with an example later. Inline alternatives, cascading information, and spreadsheet integration. This turned out to be a big thing. Some well-established companies do a lot of their management with spreadsheets. So why use Tcl? It's size and power and a fun idea. So we can define the keywords as Tcl commands. We noticed the similarity before. And we get, as a bonus, direct interpretation. We don't have to compile it into another language. We don't have to write our own scanner and parser for this, for Gherkin or our Gherkin extensions. We get debugging, and we even, excuse me, we even get to inline Tcl code. Because the best debugging is done with the little puts. Okay. So there are a few gotchas, semicolons, square brackets, quote marks, initial command name, and we'll see, because we're coming from the Python version of Gherkin, there's even a little Python problem. So the semicolon quirk, normal text sometimes includes semicolons, and the problem is if we're directly interpreting commands as Tcl, Tcl also looks at the semicolon. Here, for example, the scenario is meant to be titled Cold Start Arctic. Well, that semicolon is going to throw us off. And the second semicolon was probably pretty loud. That'll wake up the audience. The second semicolon here is not really a big problem. It'll just disappear. because what I do is use the unknown proc, and if it's unknown, then I just tack it onto a comment that's hung onto the previous command. So one solution to this is people have to start quoting things if they're using semicolons. It's a bit annoying, but it's a workaround. The square bracket problem, sometimes, rarely, you see square brackets, but if people are using references, some sort of footnote notation, you might see more square brackets than before, and you have to deal with that in Tcl as well. The quote mark quirk. Okay, this is not going to break anything, but these quote marks are going to disappear because the scanner is going to say, oh, here's a word, and I won't give you the quote marks with it. That might make it a little strange to read later. So if we can get people to use tick marks, then they'll still be there. The initial command name quirk, that can crop up occasionally just because of line breaks. Remember I said we would get inline Tcl execution. Well, turns out set is a command in Tcl, and it's going to swallow this whole, and something strange is going to happen. So I don't have a good solution to this. I just made an empty command, and I can put that in front of an area where there's a problem, and it'll disappear. The second case here, the AND statement looks like it's the start of a step. That would have been that's why I have two here. The semicolon and the AND statement together is sort of the worst case of a hidden problem. And finally, Python deals with this by saying, oh, we have these great triple quote strings. We'll just make everyone, or let everyone use them to hide things. So inside one of their strings, the set of 6 disappears, not a problem. The semicolon's not a problem. I couldn't do that, so I just used triple curlies. But now we can digress a bit. So remember when curly followed by a word was a syntax error or a scanning error, since we don't have syntax? Well, the same thing's still true with these double quotes. If you immediately follow the closing quote with some other text, then you're going to get an error. But maybe we can get a new, bump the Dodecalogue up to a Tcl and leapfrog both Python and Lua. So we could support Pythonic strings and even make a distinction between where we want a different type of replacement. For example, in the Pythonic strings, a \n becomes a new line, and we might want to keep that. But a dollar variable name string is not going to have a special meaning. We can pick whether we want that or not, or if we want to go the Lua route and say a literal string, and even use that if we're going to implement CMake in Tcl. So this is just fantasy. And now back to what we looked at. So trailing clauses. The idea is we don't want \new lines at the end. We want people to have short lines that they can look at on their screen and read out loud. So a trailing clause here is like this with. If we put the with of confidence on each line, they would get too long for the screen. So we looked at adding a new step that's basically a continuation of the previous step. So this would mean that the wheel speed is 1,001 RPMs with a confidence of a certain level, and then we can test that internally. So, another thing we looked at are inline alternatives. This turns out to be more syntactic sugar than something desperately needed. But the idea is that we recognize variants within easy notation and then generate In this case, the 6 different test cases that would be required in just one scenario. In cascading information, we saw before that the scenario outlines were at the bottom of the structure of the hierarchy, and there the tables were read in and generated tests of their own. Well, it turns out that much higher up in a feature, you might want to set a context that then trickles down, cascades down into your states. For example, you write tests that say no power to wheels during an emergency given the mode is not normal or shakedown. Well, at the time I wrote that test, those might have been the only modes that were interesting, but during development, they may have added new modes. And instead of having to go back and change or change the lower levels at each time where a new mode has come in, would give the mode in at the higher level and let it fail these tests because, okay, something has changed. For example, if you originally design a train, you say, if the train is on fire, don't move. Stop, open the doors, let the people out. It turns out that if you're on fire in a tunnel, you have to move. So this wasn't originally thought of. And then they went back and, oh, we forgot that. We'll add it. And now, did I test for that? Probably not. But I can find it. And this is where we start getting into spreadsheet implementation, integration. The changes often end up, oh, we'll add a new mode to that's a new line in our spreadsheet. We know which spreadsheet it contains that information, we can just add it there. And we can also add curves, particular power curves. Here's, for example, when we're powering up, you may have, they're called Kaelbling curves. I should know the English word, but I don't. Anyway, you may have several points along a curve where you want to make measurements, and you say, okay, that's not my approximation to a smooth curve. If you start adding these things, then suddenly you're adding columns instead of just rows to your spreadsheets. So we looked at a way to make that generic, to have the Tcl code or the code read out of the table what columns there were based on patterns and use them to generate more tests without having to go in and rewrite the tests. And this is just an example. The idea here would be to use something like SQLite. You make a query, it pulls out all the values that are in there. If they deleted some or changed some, the test is going to reflect that. I don't have to change the test itself. And here's just an example of what we might get out of one of the spreadsheets or data files. So as far as lines of code, I can't compete with the 500,000 that we heard about yesterday, but I tried to structure this pretty modularly. Turns out the biggest file is the one that handles the command line. And it's just because every Python behave option has a corresponding value in there so that I can deal with every possible option the users are expecting. Then there are various libraries, and then I mix-ins and modules for each type of statement. So the background, the description, the environment, each step. And we end up with 23 files and about 2,000 lines of code and not quite as many comments. And then I counted the tests separately. And fortunately, I ended up with more lines of test code than I ended up with lines of source code. So, in fewer files. So I'd like to answer any questions now, and just to summarize, there are good extensions and misspellings, but the cascading information seemed like a good idea. The spreadsheet integration was a good idea. The other stuff was nice to have and could be easily done, was easily done with Tcl. And Tcl turned out to be a good platform because of its flexibility, the way I could basically meta program the Gherkin language right on top of Tcl. So, questions, please? Thank you.
I wonder if shoehorning this Gherkin language into Tcl with approach unknown and that isn't just ways too complicated approach. Maybe just writing a Tcl interpreter for this language, wouldn't that have been easier?
It would have avoided some of the problems. It wouldn't have been as much fun for me, though.
Okay, that's fair enough.
Yes?
How you affected the spreadsheet integration?
Comma-separated values.
Okay.
I did-
You don't write directly the next file or something else.
No, the text file was comma-separated. And of course, it would be nice to do Excel, something like that, something horrible. But because it was an experimental project, I took the easy way.
One more question. One of those Gherkin examples also had some tabular layout. How did that work with EuroTcl? I guess it will compress all the spaces.
Yeah, well, the spaces weren't important. If they were, then we'd have a problem.
It was just nice to make a tabular layout.
The tabular layout is part of behave. And if you look very closely, you'll see that this is green because I have a Tcl command that's vertical bar. And each one of these lines is then read in, and okay, I throw away the punctuation, but that's how I get my list that I then use to populate the scenarios. So it's a good thing if your command names don't have to be alphanumeric. More questions? Well, thank you very much.
Yeah.